Carlos Pascual is a physicist, and as you can see from his T-shirt, he's a free software advocate who was always looking for excuses to do more programming and less lab work. I suppose this is true as well. So I jumped into the opportunity of working in the control section at the ALBA synchrotron. And he has been developing the Taurus framework and encouraging its transition into a community-driven project.
Hello, thanks. The work I'm going to present is not my own only, it's other people involved, as you can see here. And I want to focus this talk on how you can use Taurus in both in large facilities as we are using it, but also scale down to small facilities. For those of you who don't know Taurus, it is a framework for building control and data acquisition user interfaces. It's based on Python, and it extends PyQt. It supports plugins for various distributed control systems, and also for other kind of sources, data sources. It is a community effort. It was initially started at ALBA, but now it is the development effort is shared by several institutes. It's mainly used by European facilities, although now a few of other institutes worldwide are starting to at least get interested in it. And there are also companies that are providing services based on Taurus. Okay, so how does Taurus, what is the structure of Taurus? Taurus provides Qt widgets with some added intelligences, and these widgets interact with the data sources that can be from middle layers like this, or they can be just some hardware plugged into the computer. As I said, the widgets interact with these data sources via model objects provided by the Taurus core. And actually, it is plugins to the Taurus core that are in charge of exposing the internal data from the data sources to the widgets in an abstract way. So, for example, the Tango plugin for Taurus will show a Tango attribute as a model, as a Taurus attribute in the Taurus world, and the ALBA-CELLS plugin will expose an ALBA-CELLS PV as a equivalent attribute in Taurus, a model attribute in Taurus. Okay, so to get into the part of how we add new support for a new data source, let's imagine this very simple case where we want to have a graphical user interface that maybe is looking at our control system, but also we want to provide information that has already been stored in an HDF file. Let's say we have this file with this structure inside. It's Nexus, sort of. So we have different approaches for doing this. One is using the distributed control system that you can think of it as a specialized set of tools. And if your system provides the right tool for doing what you want, then you can just access the data directly through it. This is how you would do it with Tango, for example. You would write or find H5 reader device server. You would register it into the system, into the Tango system, and launch it. And then from Taurus, you would just, for having this interface here, you would just pass a URI, a name for an attribute based on the Tango plugin. In this case, this device server, for example, would just be allowing you to enter in one attribute, enter the path of the file, an internal path inside the HDF file, and then provide you with the value that we had here. Okay, so I said this is one approach, but there are other approaches. I am going to focus on this tool here, which is the evaluation, the evaluation scheme plugin, which is, it can be thought of a Swiss Army knife because, yeah, maybe it's not the perfect tool for any task, but it's a pretty good overall tool for many things, and it is very light and very easy to learn. So in this case, with Taurus, without using any Tango or ALBA-CELLS or anything behind, you could just encode some Python code in the name of the attribute. Yes, it is a much uglier attribute now, but basically it allows you to use the H5Py standard module to dynamically create an attribute that can be seen in a Taurus form. And you see the same thing. There is another approach, which is writing a specialized tool, creating a specialized tool for this very specialized task. So here you can see, in this case, we have a very specific task we want to do. We can just create a plugin that does exactly what we want. This is what we did, just as a way of making an example. We created a plugin and that is not distributed with Taurus. You can add it later on to Taurus. Basically, you just have to register it into Taurus after installing it, and then you can access the same data using this URI that uses the new plugin. And again, you access the same data. So these ways of accessing these different ways of accessing the data allow us to scale and adapt to the different contexts where Taurus may be used. So this is the question that I want to address in this talk. Basically, can Taurus work on a large facility? Will it work well if we have lots of machines involved and lots of attributes? And will it also work well for small laboratories? Here is the ALBA control room. So I will use this for a large facility it's not CERN, it's not SKA, but there are still, you can see that there are many GUIs here. Most of them, almost all, are built on Taurus. So in ALBA, we are using Taurus with Tango for controlling everything, the beam lines and the machine. We have created around 100 GUIs. There are around 300 machines in the control system with 10 Tango databases, and in the order of hundreds of thousands attributes that are accessed. So in this context, if we have some new hardware, let's say USB microscope that we want to access, basically for us the natural way of doing it would be to write a new Tango device server for this, maybe using some existing framework like Lima, but essentially we would just integrate it into Tango. But if you are thinking on a very small laboratory, something like the same microscope, but on a single computer, in this case even on a Raspberry Pi, maybe you could do the same thing. There is no problem. Actually, a Raspberry Pi is enough for running the Tango database and a device server for this microscope, and also showing the graphical user interface. So yes, you could use the same approach of that we use in a large facility, just scaling it down. And this, you could do it easily. Here in these three commands, we are installing Tango and Taurus with a Tango database and MySQL, everything in a Raspberry Pi. And then, just as I showed before, you would write the device server and access it with something like this. This approach, I would recommend it if the person in charge of doing it is already familiar with Tango or ALBA-CELLS. If not, maybe the overhead of learning all this is too much. Also, if the hardware is already supported, if not, you have to write your own IOC or your own device server. Also, if you do not mind the extra layer, the communication overhead, for your application. And it's definitely something you should consider if you plan to extend your setup, because then you can get a lot of benefit from a distributed control system. But just as we saw before, we can use the evaluation scheme to connect directly to the same hardware without any Tango or other distributed control system, as we see here. And you see the same, you can see exactly the same using URI like this by installing JustTodos. That's the way I would go if I was setting up a single machine system, or also for quick prototyping or on-the-fly support of hardware. It can happen, for example, even in a large installation that someone comes with some hardware to an experiment, and you can just quickly test if you can integrate it in your GUIs by using this kind of approach. This is my final slide. I just want to give a bit more examples of what you can do with the evaluation scheme. The evaluation scheme has been updated recently. That's why I'm stressing this. One of the new things of the evaluation scheme in the latest version of Taurus is that you can use any module or class instance as an evaluation device, as an evaluation model. This means basically that, for example, if you can access any Python module, like the datetime, to create Taurus attributes, like here. So you don't need to write a device server just to have the date in a graphical user interface. Same thing here with the OS system. Then it also is important that it allows mathematical operations with other attributes. So you can do things like dividing two attributes from other schemes. Like here, we have a Tango attribute divided by H5 file attribute here. And also that you can, that it supports writable attributes. Basically, if the module that you are, the class that you are interfacing provides some Python property that is writable, then the corresponding attribute that it is created will be writable. So this is also a very flexible and quick way of programming support for some hardware. You just wrap your access in a small class with Python properties, and that's all you need. So just this is the summary. We have been already using Taurus in large facilities, and we have seen that it scales roughly as well as the underlying control system, but also that you can run everything full distributed control system into a single Raspberry Pi with Taurus GUIs on top of it. Also that you can use Taurus without any distributed control system behind, and that the evaluation scheme has been proven very good for quick prototyping. Thank you.
We have time for 2 questions. There's one.
Yeah, thanks for your talk. I have a question. You have presented this form interface. So how do you actually create like more complex GUIs? And in kind of referencing to the first talk, is there any way kind of to use like templates to enforce like a consistent look and feel or something like that?
Yep, I avoided that part of Taurus in this talk because I wanted to concentrate on the data access. But actually, Taurus also provides another layer here, up here, that basically allows you to construct full applications with many Taurus widgets or other Qt widgets without having to program, just by giving standard widgets and providing them with the model names, and these widgets will be used transparently. They will be put in the application without you having to program them. Or still you could use a Qt designer and put them however you want, if you want more customization.
Okay, one more question, yes?
My question is on the interface between your user interface and the underlying data source. What are the requirements in terms of connection? Does it need to be on the same network? Can it be also on a wider network?
Basically, you just have to provide for, if you want to create one plugin like this to something that is not already supported, you would do it with Python, anything that you can access with Python. So it could be sockets, it could be whatever, Serum queue, whatever you want, or a serial line, anything that you can actually control with Python. You would create a module that wraps that and provides a few objects. It's an attribute object, a device object, and an authority object, basically. I don't know if that answers. No, they can be connecting to anything. Maybe they are not on a network at all. For example, the H5 file thing would be just looking locally into a disk, so not even networked.
Okay, I think we should maybe carry on offline. Thanks again, Carlos.
Thanks.